When we start multiplying with more than a binomial, well, we're first going to start with binomial, but we do have extra steps involved. And with a binomial, we are going to start talking about something that may feel a little foreign to some of you who are used to the FOIL. FOIL is really just a mnemonic. It's a way to remember how to do something, or make sure you do everything that you're supposed to do. And what we're going to do is we're going to use the basics that FOIL is based on, so we can sort of go further with it. And then in the next video, I'll talk a little bit about FOIL and some of the other shortcuts that we are familiar with. So in this first one, we see that we've got a binomial times a binomial. And when we do this, we take the first term of that first binomial and multiply it by the second binomial, and then we take the second term of that first binomial and again multiply it by that second binomial. So what I have written out here is really just sort of what I just said. Here's the first term of the first binomial multiplied by the second binomial. Here's the second term of the first binomial multiplied by the second binomial. So once we see it like this, hopefully we realize that all we have to do at this point is distribute. So we're just going to distribute 6x to everything, and then we're going to distribute this second term to everything in that second binomial. So I'm just going to do that really quick. 18x cubed plus 12x squared. And now we're going to go ahead and move on to this part. So plus 15x squared plus 10x. And then, of course, we always look to see if there's anything that we can simplify. And in this case, we have some like terms. So we're going to combine our like terms. So we just add the coefficients, keep the variable, and we make sure that there's nothing else we can do. And we can see that they're not like terms, so we're done. There's nothing else we have to do with this thing. So now we're going to set this next one up the same way. So we're going to take 9x to the fifth and multiply it by the second binomial. And then we'll take negative 7x to the fourth and multiply it by the second binomial. And once we've set it up like this, all we have to do is distribute. So again, we're going to take 9x to the fifth and multiply it by the first term. So we get 36x to the eighth. And then we have 9 times negative 6 is negative 54. X to the fifth times x squared is x to the seventh. And now we're going to do the same thing for negative x to the fourth and get negative 28x to the seventh. And then negative times negative, of course, is positive 42x to the sixth. And then we're always looking to see if there's any like terms, and we do have some, so we have to combine those. And, you can pull out your calculator, or you can just put it off to the side. 54 and 28, they're like terms, so we just add them. Keep the sign. So it doesn't have to be anything exciting. And then we ask ourselves if we have any like terms there. And we don't have any more like terms, so that little multiplication problem is completed. Now this is one that looks a little bit different, but again, we have to remember that, let's go up to the side here. If I have something like 3 squared, we know that's 3 times 3. If I have negative 3 squared, I know that that's negative 3 times negative 3. So the exponent is telling me I'm multiplying whatever's there by itself twice. So really all I have to do is remember that this is 4x plus 9 times 4x plus 9. Now there is a shortcut to this, and I'm going to talk about that again in the next video. The shortcuts are going to be in the next video. But for now, we're just looking at it and saying, all right, well, I do it the same way. first term of the first binomial multiplied by the second binomial. Second term of the first binomial multiplied by the second binomial. Distribute 16x squared plus 36x. Distribute again. Combine like terms. Sorry about that, 81. See if there's anything else we can do, and we can see that there's nothing else that we can do here, so we are good to go. Now this one is set up a little bit differently, and it's set up on top of each other. So this is a slightly different method, but really it's the same thing, it just looks a little bit different. So I am going to show you how to do this. And for x squared plus 2x, and of course that's to the 1, so I'm just going to go ahead and write that. So now when we do a multiplication problem, remember if we had 23 times 14, we would take this 4 and multiply it by each thing. So 4 times 3 is 12, and then we'd carry that 1, and 4 times 2 is 8, and take the 1 there, and then we go to the next number and do 1 times 3, and we place it under here, and then do 1 times 2 and get 2, and then we would go ahead and add them up. This is exactly the same process that we use over here. So we're going to go ahead and do that. So we're going to do 2x to the first times 3x squared, so that's 6x cubed. 2x to the first times 5x cubed, and that gives me 10x to the fourth. Now we do the next one, so now we're going to do 4x squared times 3x squared, so that gives me 12x to the fourth. And notice how we have the x to the fourth in the same column. We only put things that have like terms here, so the x to the fourth has to go under the other x to the fourth. And now we do 4x squared times 5x to the third and get 20x to the fifth. And we just go ahead and add up all those columns the same way we did with our regular numbers. Nothing is changing except we've got some variables tossed in. And of course we don't have any like terms, so that's our answer, and we're done with that. Now let's look at a binomial times a trinomial. So again, if we are going to use this process that we are getting used to, which is taking the first term of the first polynomial and multiplying it by the second polynomial. So we're going to do 3x to the fourth times the second polynomial. It's just this time we've got a trinomial here. And this is where the FOIL method breaks down. It only works with a binomial times a binomial. And then we'll go to the second term of that first. And again, multiply that by the second polynomial. And once we have it set up like this, you can see really all we're doing is distributing again. So we've got 3x to the fourth times 2x squared. And then we're going to do times 4x. And then we will multiply it times 1. And now we're going to multiply this term times that entire polynomial again. And once we've done that, we look for anything that's the same, and we see that we don't have any like terms. So this is, sorry, that 6 got messed up. So this is our done answer. So as soon as we see we've got no like terms, we're done. let's go ahead and I'm going to suggest that you pause this video for a minute and try this one on your own. Give you a second to do that, and now I'm just going to go ahead and write this out. So first term times the trinomial the second term times the trinomial now we just distribute. Remember, you can put that 1 in there if you need it. And remember, when I'm doing this, I'm adding the exponents. Put that 1 in there again. Looking for like terms. I see that I have some. So I bring everything else down. Combine those like terms by adding the coefficients, keeping the variable. And we're done. Now the last, or one of the last types I want to show you is this binomial cubed idea. And when we've got a binomial cubed, I tend to set it up like this. And remember, of course, that when you see this, that's just 5x plus 2 times 5x plus 2. So what we're really doing is writing this out. But I'm going to go ahead and put this in a bracket to keep this separate. So I'm going to do 5x times 5x plus 2. And using that, and now I'm going to use the plus 2 times 5x plus 2. And remember, I'm going to do what's in the bracket first. I'm going to go ahead and distribute. Then I look inside that bracket and combine any like terms. Remember, I want to have it as simplified as it can be. Combine like terms by adding the coefficients, keeping the variable. Now there's nothing else I can simplify inside there, so now I'm going to go ahead and distribute the next time, which is I'm going to take this binomial that's on the outside and multiply it by what's inside the bracket. I'm going to change the bracket to a parentheses for no good reason other than I don't like writing brackets. It's a grouping symbol, so it works. So the second term of that binomial, and again, now I'm going to distribute. And once I've done that, I have to, oopsie, I just saw I made a mistake here. That's just 100. Don't know where that came from. And now I'm going to combine some like terms. So I've got 25x cubed. There's no other x cubes. But here is an x squared, and here is an x squared. So I can combine those by adding the coefficients. Keep the variable. Now I'm going to add the x terms. Again, add the coefficients, keep the variable, and the constant, there aren't any other constants, so I just bring that down. There are no like terms, so that is done. Now this is the last one that I'm going to do an example of. This is a trinomial times a trinomial. And again, this is sort of where that FOIL idea sort of falls apart, and if you can get used to this multiple uses of the distribution property, the distributive property rather, it works out much nicer. So again, I'm going to take everything that is in the first parentheses and multiply it by the second parentheses. So I will start with the 4x to the fifth. multiply it by the second parentheses. And you may want to put the 1 there if you need that coefficient to remind you. Then we take the next term of the first parentheses. Don't forget the sign, don't lose that sign. And then the third term of the first parentheses. And now we just distribute. So be careful when you're doing this. Careful of the signs. That's one of the places that we like to make mistakes. Okay, so we've distributed. So this is kind of a mess, but that's okay. So now we're just going to look for, we're going to put it in order, and we're going to start with the highest exponent first. So the highest exponent in this case is this guy, so we're going to do 8x to the 8th. Now we're going to look for, and there aren't any other 8 exponents, so we're going to look for 7 exponents. And we see that we've got 2 of them, so we just combine those. That gives us plus 30. Now I'm going to look for powers of 6, and I messed this one up. There we go. And see, powers of 6. So we've got power of 6, power of 6. Again, combining those coefficients. Power of 5. And the others don't have any other mates, so we just bring them down. We check to make sure that we've got all of our like terms, and then when we don't, we see we can call it done.